Page 5 of the Chapter 6 review. So we've got this graphing. We're going to graph and label A prime, B prime. Now, since the center is the origin, we can just multiply the coordinates. There's no shift. We can just multiply and place them. So those are the new coordinates, and we just graph them. Should be 3 times as big and further away. Okay, next we're going to calculate the length to show that A prime, B prime is 3 times as long as AB. So going through the process here, I always do Pythagorean theorem. You can always use the distance formula. I just, do it this way. And then we get to a situation where we have square roots that can't be nicely reduced. So, well, we can reduce them, but we can't get them all the way down. So they're decimals, they're irrational numbers. So what I did, instead of simplifying both, I just simplified the square root of 180 enough to show that A prime, B prime is in fact 3 times as much as AB, because it's 3 times the square root of 20. And AB is just one of the square roots of 20. So we'll write that up as best we can. Okay, so A prime, B prime is 3 times AB because square root of 180 is 3 times the square root of 20. It's good enough. Next, we're going to try to show parallel. Anytime we show parallel, it's going to be slopes on the graph. So we're going to have to calculate the slopes first. So what I'm doing is rise over run for both of them, AB. The rise is 2, the run is 4, and it's negative because as we move left to right, it's going down. So that's where that negative is coming from. A prime, B prime. The rise is 6, the run is 12, going negative. Okay, so now I'm going to simplify and just show you. I'm going to factor out a 2, which leaves me negative 1/2, I should say. And then I'm going to factor out a 6, which leaves me negative 1/2. This shows that those are equal. So they're the A prime, AB and A prime, B prime are parallel because they have the same slope. All right, for this one, it's a dilation. So what we're going to have to calculate is the center and scale factor. So to get the center, we could use a straight edge. And what I'm doing is I know the center is somewhere on the path that connects F and F prime. And it's also on the path that connects G and G prime. So wherever those 2 straight paths intersect is the center of dilation, right here at 3, 2. So that's how we calculate that. Use a straight edge and find the center, 3, 2. Scale factor is, I always just go in one direction. If I can just go for the change in X, I do. So the change in X from the center to our pre-image is 2. And then from the center to our image is 6. So our scale factor is going to be 3. 6 over 2 is 3. That's it. Dilation centered at 3, 2 by a scale factor of 3.